All right, welcome back. A little bit of a change of plans. I know I gave you guys factoring sheets, and I told you that the snow day videos were going to involve factoring, okay? But what I want you to do instead, save those factoring sheets, because instead of factoring on these snow day videos, we're going to be simplifying logarithmic and exponential expressions, solving logarithmic and exponential equations, and we will work on those factoring sheets when you guys get back to class Monday. So a little bit of a change of plans here. But in fact, this is going to save us a lot of time. This is an idea I came up with. This topic is generally not covered till later in the course. But I'm thinking through it. I thought, well, you guys already have the skills to do this, most of this, not quite all of it, but most of the information in this topic you're already able to do based on what we've already covered in this class. So this is actually going to save us a lot of time, and it's pretty simple. Okay, what you're looking at is something that has a value. Log base 2 of 64. These are your 4 homework problems over here. I need the number. What is this equal to? What is the value of this? What is the value of this? And what is the value of this? They're all fairly simple. Find the value. Okay, and reminding you that expressions have what? Expressions have values. So you're finding the value of each of these 4 expressions. Now, if I told you here, find the value, you don't know what it is. Like just looking at this, it makes no sense until I show you. So to get started with these, what we do is we actually work in both branches. We're going to be working in the expressions and the equations. So you're going to be working together. To find the value of the expression, you're actually going to take this and set it up as an equation and solve an equation to find the value of the expression. It kind of goes hand in hand. I think this is rather interesting. But let's go ahead and just get started. If I write log, and you're already familiar with this notation from the parent functions list given earlier this year, log base a, little tiny a, of x is equal to y. Let me write it bigger. Log base little a of x is equal to y. This is how we read it. Log base a, little tiny a of x is equal to y. And what does this mean? Well, we're going to rewrite this, put an if and only if arrow. Not going to explain really what this means other than it goes both ways. But this arrow just means this is represented by something else. So I want you to just put this arrow. This arrow represents the words if and only if. And we're looking at log base a of x equals y. Circle a and write base, circle y, and write exponent. Now, reminding you, if I write on the board 3 squared, okay, 3 squared, we know the value is 9. However, 3 is the base, and 2 is the exponent. Okay, 3 is the base, 2 is the exponent. So notice here, a is your base, y is your exponent. So the base, I would say this, base, once a base, always a base, base on the bottom. Once a base, always a base, base on the bottom. Base is very small in the logarithmic equation, but when we rewrite it, the base is much larger. Watch. So now we're going to write a large A because A is the base, and the exponent y is now written very small. So we have a very small y equals x. So notice the base A is written on the bottom, and the exponent y is written small because when we generally read, the base is written larger than the exponent. So a to the y is equal to x. This expression, or up top, is called the logarithmic equation. And on the bottom is the exponential equation. These go hand in hand. They actually mean the same thing. Exponential equation, well, they're inverses of one another. We'll talk about that later, but they're very much related. Okay, so the logarithmic equation, this is your exponential equation. All right, now, I'm going to rewrite this information over here. Don't worry, this looks complicated, but it's actually quite simple. Let me write. Okay, so log base little a of x is equal to y. Circle the a is the base. Circle y is your exponent. Okay, now, okay, so once a base, always a base, base on the bottom. This is your if and only if symbol. Okay, it means, what this says is this here. The symbol means the top is the same as the bottom. Think of this as an equality symbol. Okay, so what does this mean? This means that our base is a. Write the a much larger now. The base is a, and the exponent, go ahead and write it very small. Okay, so the exponent is y is equal to what's left. It's equal to x. Now, let's go ahead and solve some problems. These are actually pretty simple. Okay, so we're looking at, first, let me grab my sheet. Log base 2 of 128. Okay, so you're asked to tell me the value of this expression. And if I said, here, tell me the value, you look at it and you say, well, I don't know what this value is. I have no clue how to even do this yet. So instead of evaluating the expression, remember that expressions have values. If I say, give me the value, you don't know what it is. So what you have to do is you have to set this up as an equation. Watch. We don't know what this thing is equal to. So write, well, it's equal to something. So let's write equals question mark. Now in algebra, we don't use question mark. We use a variable to represent something that we don't know. So instead of writing question mark, what are we going to write? We're going to write a variable. Now you're used to writing x, but I want you to use variable y instead of x. This is just convention. So we're going to say log base 2 of 128 is equal to something that we don't know. Okay, so you're going to set this equal to y, and what you've created, you took a logarithmic expression, and now you've created a logarithmic equation. Okay, now the logarithmic equation is going to be rewritten. It's going to be rewritten as an exponential equation. So watch this. So our base is 2. Circle the 2. This is the base. And circle the y. Y is the exponent. Okay, so base is 2. And y is the exponent. Now we're going to rewrite this as an exponential equation. So we're going to take our base 2 and write it larger now. So the base is 2. And our unknown is the exponent. So the exponent is y equals, what's left? It's equal to 128. So you end up with this, what we call the exponential equation. Now on your homework, I want you to label this. I want you to label up here, this is the logarithmic equation. And down here, I want you to label this is the exponential equation for each problem. Okay, so this is the exponential equation so that you know the difference. This is logarithmic equation, this is exponential. In order to solve a log equation, you have to rewrite it as an exponential equation. And now it's just a matter of factoring. So we say 2 to the y is equal to 128. We have to take the 128 and break it down. It's a lot like what we did with radicals. So take 128, break it down. This is what? 2 times 64. Break down the 64, which is 2 times 32. Break down the 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. And we count. How many 2's give 128? 1, 2, 3, 4, 5, 6, 7. So we're going to rewrite 128 as 2 to the 7th power. So we end up with 2 to the y equals what? 2 to the y equals 2 to the 7th power. So if 2 to the y is equal to 2 to the 7th, let's think for a minute. 2 to some power, we don't know what y is. Okay, 2 to something is equal to 2 to the 7th. We can use a logical step here and say, well, if 2 to some power is equal to 2 to the 7th, it must be the case that y is the same as 7. So we can now solve the equation and say that y equals 7. And that is our answer. This is our answer. So now I want you to write this back up here. We're going to now rewrite this. Rewrite this as log to check our answer. Let's check our answer. We say that the answer is 7. So we're now going to rewrite this as, just bear with me, if you're struggling to understand this, the first example, I think you'll get it after example 2 or 3. But to check our answer, we say that the answer is y equals 7. Now notice equals y is written here, so we're going to put the 7 back in for y, and I want you to write log base 2 of 128 is equal to, instead of y, let's check and see if this is equal to 7. Now, circle the 2, 2 is the base. Circle the 7, 7 is your exponent. And let's check our answer. So we're going to say the base is 2, so go ahead and write 2 as your base, much larger. And your exponent is 7 is now written very small. 2 to the 7th is equal to what? 128. And now let's check and see if this is true. Well, 2 to the 7th power means what? 2 times 2 times 2 times 2 times 2 times 2 times 2. There's 7 2's. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. And we have times another 2. So 4 times 4 is 16. Times 4 gives what? 64 times 2, which is 128 equals 128. So this checks out. All right, now let's look at another example. Just bear with me. This actually will become very simple once you guys get it. Let's look at that example number 2. So this is just like, example 2 is just like problem 2 on your homework. All right, so we're looking at log base 3 of 729, and you have to find this value. Now, if I look at this, I say here, tell me the value. If you don't know what it is, just looking at it. So instead, we're going to call it something that we don't know. Something that we don't know. Something that we have to find. Question mark. Instead of using question mark, we're going to write this as what? Equal to y. Something that we don't know. So we have to find what y is. If we find what y is, then we know what the value of the expression is. This expression is equal to something. Now, circle the 3. 3 is your base. Circle the y. Y is your exponent. Okay? And we're going to rewrite this. The base 3 is written on the bottom. Okay, so base is 3. Written much larger. And now your exponent is written very small. 3 to the y power is equal to what? Is equal to what's left. It's 729. Now, what we have to do is we have to factor down to what we say the same base. Factor down to the same base. We want to get 729 to a base 3. So we're going to take 729 and break it down. So 729 is, I'll help you out. You remember, something is divisible by 3 if the digits add up to a number divisible by 3. What is 7 plus 2? 7 plus 2 is 9 plus 9 gives 18. Since 18 is divisible by 3, 729 is also divisible by 3, and I'll help you with this. The 3 times what? Well, 3 times, if you take 3 into 729, you get 243. Now, break it down again, which is 3 times 81. 81 is what? 9 times 9. And we can break the 9s down. We get 3 times 3, 3 times 3. How many 3's multiply to give 729? If you count them, 1, 2, 3, 4, 5, 6. So we have 6 3's that make 729. So we're going to write 3 to the y power. Instead of writing 729, we're going to write 3 to the 6th power. Now think about it. If 3 to something is equal to 3 to the 6th, if 3 to some power is equal to 3 to the 6th power, then it must be the case that the exponents are the same. If the bases match, in this case, and we say that these are equal, it should be the case that the exponents must be the same. So we logically conclude that y must equal 6. So we have found the answer to our problem. What is the value of this expression? What is the value? What is the value? Question mark. What is the value? The value is what? The value is 6. So log base 3 of 729 is equal to what? Is equal to 6. Let's check our answer. I think checking the answer makes it come to life. Okay, so let's go ahead and see if y is actually 6. So let's check our answer. This makes you look at it a little bit differently. So we're going to write log base 3 of 729. We're saying this must be equal to what? This must be equal to 6. Let's see if this is true. Circle the 3. 3 is the base. Circle the 6. 6 is your exponent. And we're going to write what? 3 is the base. 6 is the exponent. 3 to the 6th power equals what? 729. Let's check and see if this is true. 3 to the 6th is 3 times 3 times 3 times 3 times 3 times 3. Each pair of 3's gives 9. 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81 times 9. 81 times 9 is 729. Is equal to 729. Yes, this checks out. Okay, so 2 problems solved. So tonight you have to do log base 2 of 64, log base 3 of 243. Now let's look at these other 2 with the fractions. It's pretty just as simple. So let's look at, and again, this kind of goes hand in hand with your laws of exponents and the concept. We broke numbers down dealing with radicals, so I think this is very, very, actually probably you're more familiar with this now than later in the course when it's been a while since we've reviewed exponent laws. So I think this might actually be a little easy right now. Log base 3 of 1 over 729 is what you have to find the value of. Okay, so this is just like homework problem number 4. And what we have to do is say, well, we don't know the value of this thing, so we're going to say let it equal y, something that we don't know. Now again, our base, this is our base. I'm just going to write b for base, and y is the exponent, e for exponent. So we write the base is 3, large 3, and the exponent is written very small. 3 to the y equals what? 1 over 729. And now what we're going to do is break down the 729. We just did it in the last problem. 729 is 3 times 243, which is 3 times 81, which is 9 times 9, Break these down, 3, 3, 3, 3. How many 3's multiply to give 729? There are 6 of them. So we're going to say 3 to the y, 3 to the y is equal to 1 over, instead of 729, 3 to the 6th. Now, the way to solve this is just a matter of moving it from the denominator to the numerator. Okay, so 3 to the y is equal to 1 over 3 to the 6th. Remember, whenever we move, I should say negative exponents mean move from top to bottom or move from bottom to top. Numerator to denominator, denominator to numerator. We can also take a positive exponent and move it. Okay, so we're going to say 3 to the 6th power moves to the top, and the exponent changes from positive to negative. So we're going to say that 3 to the y is equal to, if 3 to the 6th moves to the top, then we end up with what? 3 to the negative 6 over 1. So if we move it to the top, the exponent changes from positive to negative, and we don't have to write the over 1. So we end up with 3 to the negative 6th power over 1. We take the 3 to the 6th, move it to the top. The exponent changes from positive to negative, but we don't have to write. What's left on the bottom? Nothing. And what do we write? A 1. But we don't have to actually write over 1 in this class. So we end up with 3 to the y equals 3 to the negative 6. Now, if 3 to the y is 3 to the negative 6, if the bases match here, we must be able to logically conclude that y is equal to negative 6. And now, we're saying that the expression has a value of negative 6. So the answer is negative 6. So let's check our answer. Okay, so checking the answer says, let's put it in. So put negative 6 in for y. We get log base 3 of 1 over 729 is equal to negative 6. And let's check and see if this is true. 3 to the negative 6th power, so we get the base is 3, and the exponent is negative 6. This is our base. The 3 is the base. Negative 6 is the exponent. Negative 6 is the exponent. And so we say 3 to the negative 6th power equals 1 over 729. Yes, this is true, because we take 3 to the negative 6 and move it where? Move it where? Move it to the bottom. Okay, so we end up with what? We end up with 1 over, negative exponents mean move from top to bottom. We get 1 over 3 to the 6th power equals 1 over 729. And now we can evaluate 3 to the 6th power. If we take 3 times 3 times 3 times 3 times 3 times 3, we get 1 over what? We get 1 over 729 is equal to 1 over 729. So the answer checks out. Now, last example. Hopefully by this point you're starting to pick up on this. Last example is log base 2 of 1 over 64. No, I'm sorry. Log base 2 of 1 over 128. Log base 2 of 1 over 128. Okay, again, we don't know the value of the expression, so we're going to say it equals something. What are we going to call this? We're going to call this y. Now, our base is what? Base is 2, and y is the exponent. So we're going to say the base, write it much larger. The base is 2. The exponent is y equals 1 over 128. Now take your 128, break it down. This is 2 times 64, which is 2 times 32. 2 times 16, which is 2 times 8. Which is 2 times 4, which is 2 times 2. How many 2's multiply to give 728? 1, 2, 3, 4, 5, 6, 7. So we say 2 to the y power is equal to 1 over, instead of 128, write it as 2 to the 7th power. Remember, we can take the 2 to the 7th, move it to the top. And if it moves, the exponent changes from what? Positive to negative. So we end up with 2 to the y is equal to 2 to the negative 7th power over what's left on the bottom if the 2 to the 7th moves to the top. Nothing is left. So if I say nothing, I mean a 1. Okay, so nothing does not mean 0. Nothing means a 1. We move it to the top. There's a 1 left. We don't write over 1. So we just end up with 2 to the y. 2 to the y equals 2 to the negative 7th. And if 2 to the y is 2 to the negative 7th, we can logically conclude that y must be the same as negative 7. So we say our answer is y equals negative 7. Now again, check your answer. To check the answer, we plug it back in, and we say what? We say, well, if y is negative 7, then what we're saying is that log base 2 of 1 over 128 is equal to what? Negative 7. Okay, now let's check. So our base is 2. Exponent is negative 7, so we say 2 to the what? 2 to the negative 7th power is equal to 1 over 128. We take the 2 to the negative 7th and move it where? Move it to the bottom, so we get what? 1 over 2 to the 7th power is equal to 1 over 128. And yes, if we take 2 times 2 times 2 times 2 times 2 7 times, we get a 1 over 128 is equal to 1 over 128. And that concludes this video. And there should be, I'll probably post 1 or 2 more videos on this. And so look for them coming up. But tonight's homework, hopefully this makes sense. And in the next video, I will go a little deeper into logs. So I think this will start to make a little more sense for you. But anyway, good luck on your homework, guys.